Okay, so this is the video for section 2.2, day 1. Just a quick review of what we know from chapter 1 and section 2.1. The derivative. We have learned how to take a derivative by definition. And by definition, what we did was the limit as h approached 0 on f of x plus h minus f of x all over h. And that's how you had to take your limit on your the extra credit on your test, and that is also how you were doing the limits for section 2 on both the homework assignments. What we're going to learn today is some shortcuts for limits. So if I ask you to take a limit by definition, then you have to do it the long way, but if I don't say by definition, then we are going to learn a bunch of different rules for taking a derivative, and you can use those shortcuts to make things easier. So you have a worksheet on Angel called Math Section 2.2, Rules of Differentiation. And that's what I wanted to go over in this video so that you're able to use these new rules to do your WebAssign. So the first rule for differentiation is the constant rule. And it says that if you take the derivative, and this d dx, remember, is like a verb. It says take the derivative of what's in the brackets, and the x says with respect to x. So if you take the derivative of a constant with respect to x, you get 0 every time. If you d dx the number 7, you get 0. If y is 1/2, which is a constant function, and you need to find y prime, which is the derivative, it's 0. If your function is s of t, and it's a constant, 6.5, and you have to find s prime of t, or the derivative of s, it's 0. It's really easy to show why the constant rule works, so I'm just going to flip back over to here a minute and show you why. If your function is the number 10, and you apply the rule for derivative, you do the limit as h approaches 0 of the function evaluated at x plus h. The function evaluated anywhere is 10. So when you evaluate it at x plus h, it's 10. When you evaluate it at x, it's 10. It's always 10. And so that means that when you take this limit by definition, you're taking the limit as h approaches 0 on 0 over h. And so if this number gets closer and closer and closer to 0 but never gets there, 0 divided by that number will be 0. So you can see easily by definition the limit of a constant is 0. I'm not going to prove all of these by definition, but you can see the proofs of them in your textbook if you're interested in that. The next rule is called the power rule. If you are taking the derivative of x to a certain degree, the shortcut for how to take that derivative is the degree moves down and becomes your new coefficient, and the new degree for your derivative is the old degree minus 1. So this is a rule that you can use to find the derivative of x to any power. For example, the derivative of x to the 9th power. The 9 moves down and becomes your new coefficient, and your degree is 9 minus 1, or 8. So what you're physically doing is you're taking the 9 and it is becoming the coefficient of your answer, of your derivative. And then you're taking the 9 that was your exponent and subtracting 1. That's how we're applying this rule, and that's where 9x to the 8th is coming from. You have to be careful if your exponent is less than 1, and you do that, and you take the derivative of y, which is t to the 1/2, you're going to pull the 1/2 down in front. You're going to drop the degree to 1/2 minus 1, which is negative 1/2. But you know that you would not stop there because a negative exponent in your answer is never an okay way to leave your answer. So you would want to create a fraction and put the negative exponent down in the denominator and rewrite this as 1 over 2t to the 1/2. Or if you prefer, 1 over 2 square root of t. So there are times when your exponent was positive, but since you're subtracting 1, it goes negative, and you need to deal with that before you finalize your answer. There's also times where your exponent is negative to start with, so when you move the -3 down to be your new coefficient, and you subtract 1 from your exponent, -3 minus 1 is -4, you again want to remember to rewrite your answer with the x in the denominator because it had a negative exponent. What a lot of people do is mess up because they think that when they move the x to the denominator, the -3 will also go down. But we dealt with that earlier in the semester. We said -3 is to the first power, so the -3 would stay in the numerator, x to the 4th would go to the denominator. That is the power rule. And the final rule for today is called the constant multiple rule. And what it says is, if you're taking the derivative of a function of x that has a constant out in front of it, you can move the constant out of the derivative process. Move the constant out of this verb that you're doing to the function and just take the derivative of f of x. So the derivative with respect to x of a constant times f of x is the same thing as c times f prime of x. An example of this looks like this. If you're going to take the derivative of 5x squared, so 5 is your constant multiple, you don't need to consider the 5 when you're taking the derivative. You can move it outside and just take the derivative of x squared. And when you take the derivative of x squared, you're going to use the power rule. So you're going to move the 2 down to be your new coefficient, and your degree is going to drop from 2 to 1. So the derivative of x squared is 2x, and the 5 that you pulled out can then get multiplied on to be your final answer. Sometimes it doesn't look like a constant multiple. Like if you have x squared over 5, you might not think about this 5 as a constant multiple, but you have to. You have to know that if the 5 is in the denominator, it's the same thing as 1/5 times x squared. So your constant multiple in this case is a 5th. You pull the 1/5 out, and then you take the derivative with respect to x of x squared, which we already said was 2x. So now my derivative would be 1/5 times 2x, or 2x over 5, or if you prefer, 2/5 x. However you want to write your answer. So we have 3 rules, the constant rule, the power rule, and the constant multiple rule that we're going to do these examples on. But the most important thing is before you take the derivative, you have to know what the constant multiple is and what the exponent is on x. Those are the 2 questions you have to ask yourself before you can take a derivative. So looking at this example A, your